Hey guys, welcome to this malware analysis and reverse engineering lab. So far we have studied static analysis. So we have did some analysis on two malicious files, and we have answered some questions, right? So whether this malicious file contains any strings which is related to malware, or whether it has any hashes. So we did some searches on these hashes on VirusTotal and Google as well. So we have also found some strings which has been already encoded. So we have studied base64 encoding and also XOR encoding. So these are all the things we have studied, and these are all the things which is actually a very basic thing while starting a malware analysis. So this will come under static analysis of a particular malware. The next module is actually a P header, which is very important in malware analysis. So I'm going to present a class today on P header, which will clearly explain you what is meant by portable executable file and what are all the modules actually present under this P portable executable file. So what is mean by P header, what are the sections, what are all the resources we have to get into while doing analysis. So everything I'm going to explain you in this video. So P header, this tells the OS how to run the program. So this is a main part of actually the portable executable file. So this tells the operating system how this program have to run. So it tells the OS where the pieces of the actual executable should go into the memory of a particular system. So this tells the OS and it indicates the OS as where the actual pieces of the executables which is present in the program should go to the memory of a particular system. So the third thing is it provides the operating system informations that are needed to run the particular malicious program. So it provides OS informations so that are needed to run the program. It contains all the informations that are necessary for the Windows to execute that particular malicious programs. So this P header, portable executable header, this part is actually present in a malware file which contains each and every nook and corner of the informations that are necessary for the Windows operating system to execute that particular malicious file. So without the P header, the program just wouldn't able to run in the operating system. So we can call it as actually it directs the OS. Actually the P header is actually directing the OS where to it tells where to put the different section of the program in the memory of the particular system. So how large that section of the program should be, what are the section of the programs, what actually the purpose of that program, what are all the dynamic link libraries, DLLs to load while executing that malicious file, what portions are the executable code and which are the data has to be represented, and what instruction to start at. So at what instructions, where I have to start first in the particular malicious program. And also it tells whether the program is actually a graphical user interface program or a console program or even an Xbox program itself. So in this slide we have to get a conclusion that without P header the program couldn't run in a particular operating system. So the P header is actually directing the OS where the different section of the program should place in the memory of a particular operating systems, and what are all the DLLs, supporting DLLs have to be loaded while executing this malicious program, and whether it will tell whether it is actually a GUI mode, should run in a GUI mode or in a console mode, or it should be in a Xbox program. So everything it will tell actually the PE header of a particular malicious file. So PE header, it can be considered as a container. We can tell like it contains all of the informations needed for the operating system to execute the program. So we can call it as a container. It contains every informations that are needed for an operating system to execute the program. It consists of actually. So we can call it as a director also. So because it is actually directing the OS where the pieces of the executable go into the memory of a particular system where the malicious program is actually executing. So then the right hand side I'm here give a snapshot of PE header. It initially consists of a DOS MZ header. This is MZ is actually, I said right, so it is a magic number of any portable executable file. So this is for MZ header, and followed by MZ header there is a DOS stub is there, and below the DOS stub we are having a PE file header, and below that PE file header we are having the optional header. And below the optional header we are having the section tables, what are all the section present in the particular portable executable file, and below this section table we are having different section of the particular program. I will tell you what are all the things we have to concentrate on as a malware research analyst. We have to concentrate on in the upcoming slide. So while seeing this PE header structure, we couldn't concentrate each and every part of the PE file. So I'm going to tell, as a malware analyst, you have to concentrate on some important section of the portable executable file. So the first thing is actually file header. So consider this figure in the right hand side. So this will explain the file header of a particular malicious file. Say for example, here in this snapshot they have taken an antivirus.exe as a malicious file which is located in the C colon of the malware folder. So the first section is actually called as a DOS stub, which is actually 160 bytes. This is what we don't need to much worry about this DOS stub and all. We will directly go to the file header. So the file header, which consists of while expanding this tab, we came to know that the timestamp of the particular malicious file, when it has been created, and also the location that can help us as a malware research analyst to determine when and where the malware was created and all. So in the file header, it contains much more of the information of the OS users. It includes the location of the code and data areas and the pointers to various tables and stack sizes. So this first part is actually called as a file header. You please make a note. This file header, it records the timestamps and the location where the malware and when the malware has created and all. So the second thing we have to see in the portable executable file is optional header. Under PE header we can call it as an optional header. So this this will give the information on the executable for the operating system, and also it tells the subsystem of the malicious file where we are actually doing the research. So this will tells what kind of interface this executable needs, whether a graphical user interface, a program, or a driver program, or maybe a Xbox gaming program. So the right hand side of the slide, I have given a snapshot where the optional header looks like. So it will come under the file header. So there is an optional header. Optional header is there. So it will tell you the subsystem, whether it is whether this malicious file needs a GUI program to run, or a driver program, or a Xbox program to run. So this is the second thing you have to note it down. So first thing is actually file header. The second thing is actually optional header. So the third thing is actually portable executable sections. So this is a very vast thing. We have to concentrate more on this thing, on this module, where the malware research analyst is going to retrieve number of data. I mean, indication of compromise to confirm the particular file is actually a malicious file. So what are all the sections which is present in the PE header are .code, .text, .data, .rdata, .idata, .edata and .rsrc. So what is .code? .code is actually an executable code. It consists of the executable code, executable code of a particular program. .text is also consists of the executable code of that particular program. If you are considering a file, that file should compulsorily it should has this .code and .text code, because this contains the executable code. With the help of this code only that program, that malicious file is going to execute. So and then the .data, this represents the program data. So for executing the code, I am also in need of some data also. So that data will be present, this program data will be present in the .data and also in .r data also. So this also consists of program data. And the next one is idata. Idata is nothing but import data or import table. So and then in the next slide I will explain you about the import table. And then .edata, which is nothing but the export data or export table, which is going to tell you in the next slide. And .rsrc, which is nothing but the resources. So while considering this section characteristics, the main characteristics of a particular malicious file is read. It has write option. It may has execute option. It has an initialized data. It has some uninitialized data also. So only these sections that are marked as an executable can contains the code. We all know that the sections that has been marked as an executable. Who are all the sections which has been marked as an executable codes are .code and .text. So these sections should be read only and should not be writable thing. So this .code and .text should be in the readable only option. It should not be in the writable options. So some packers, some malicious authors, they will often create a sections that is marked as a writable and executable. So if they are doing so like that, I mean the writable and executable, marked as a writable and executable, so that they can place the unpacked code onto it in the memory of the particular system. So this as a malware research analyst, you have to make a note whether this code and text is in readable option or whether it is in a writable or executable option. So it should be in the readable option, since it is actually a executable code. If it is a legitimate file, if it is a genuine file, then that .code and .text should be mentioned as a readable thing only. So it should not be in the writable and executable thing. So if it has been so, if it has been so as a writable or executable, then it may be a malicious file. And the next thing is in PE section is the packers and sections. So this will give you about what kind of packers the malicious authors has been used for packing this particular malicious files and all. And also it will give the auth permission. As I said earlier, if it is write and execute, if it has been mentioning the executable code as a write and execute, then it is called actually auth permissions. So you have to make a note in this slide that we are having different sections in PE header, .code, .text, .data, .rdata, .idata, .edata and .rsrc. So these are all the datas. Some of them are called executable code, some of them is called actually programmable data, some of them is called importable, exportable and resources. So we have to mention this section should be some section should be in the readable only option, some section should be in the writable, or some section should be in the executable option. So that should be, we have to note it down as a malware research analyst. So if the executable code is in writable and executable mode, then we have to make a note that file may be a malicious file. So everything I am going to show in a demo, so don't worry about how to extract the section of a particular malicious file and all. You just listen what I am saying for each and every slide. So that is very very important, right? The second in the PE section itself, as I said earlier, I am going to tell what is mean by actually import table. So import address table, it is actually the list of dynamic link libraries and the functions, or we can call these functions as an application programming interface, APIs. From those libraries the program is going to actually call. So this is actually as supporting files where the particular malicious file is in need from the operating system to execute the particular malicious file. So if the malicious file want to execute, it needs some APIs, it needs some functions, it needs some supporting DLL files, dynamic link library files from the operating system, so that the program will run without any error and all. So that thing the program is going to call from the operating system. So if the program is say for example it is going to interact with the computer, say for example it sends a data over the network, or even it is going to encrypt something in the particular system, if a program is going to execute. So if a program, what here we have been meaning here meant is the program is malicious program. If it is going to interact with the computer, say for example, if it is going to send a data over the network, say for example, if it is even encrypting some data in the particular in the system, so it is probably going to do so by calling one of the libraries which is already present in the system, as I said earlier. So every action a particular malicious file is going to do, then it needs the supporting library files, it needs supporting functions, it needs the supporting APIs and all. That supporting functions that malicious file is going to get from the system itself. For getting that malicious file from the system, they have to call one of the libraries, one and every libraries from the system. So the program will specify that library and the function in the import address tables. Now you are getting clear appearance of the import address table now. So what is import address table? It consists of the information where the malicious program is going to run. For that execution of the malicious program, it needs some supporting files. That supporting files is going to get from that particular system where it is going to run, and this information is actually present in the import address table. The program will specify the library and the functions in the import address table. This means that by looking at the import address table, we can see what functionality the malware has. So we are going to do an analysis in the import address table of a particular malicious file, and we are going to see what the functionality of the particular malware is going to do. So continuing the import address table of a program on the left, I am giving have given some example for here the import address table. So in the left hand side, here in the orange color, it is called actually the import address table of a particular malicious file. So it needs a kernel32.dll for executing that malicious file. So this kernel32.dll will be fetched from the operating system, the particular system where the malicious file is going to execute. So for that, for executing this malicious file, it wants to load the functions called virtual allocation, read file and write file, say example. This has to be get from the kernel32.dll file which is already present in our operating systems. On the right hand side, the kernel32 in the memory with the different memory locations the functions are at actually. So this is the DLL file which is present in the operating system in the victim system, where it consists of different functions. It already loaded its functions, the virtual allocation which is loaded in this particular memory, real-time on-time memory. So this is read file, this is a particular functions which is already loaded in this thing, and write file which is loaded in these things. So everything is loaded in a memory, already loaded in a memory in the operating systems with the help of this kernel32.dll. The loader will first replace the virtual allocation entry with its location in the import address table. So it will locate, say for example, this 0 cross 1 2 3 4 5 is the location of the virtual allocation function. So it has to be loaded in the import address table of a malicious file. So it has been loaded. So it has been already there, right? Virtual allocation is the function it needs for executing that particular malicious file, and hence the memory of that function has to be loaded in the import table. So it has been loaded. So 0 cross 1 2 3 4 5 it has been loaded here. 0 cross 6 7 8 9 0 for read file, it has been loaded here. 0 cross A B C D E for write file, it has been loaded here in the import address table by seeing the particular functions. Say for example, virtual allocation, read file, write file here. So everything has been loaded from the operating system towards the import address table by seeing the functions which is present in the malicious file. So this the loader will first replace the virtual allocation entries with its location in the import address table. Then it does the same for the read and the write file until all the functions have been replaced with their addresses in the memory. So you have to note this point in this particular slide. This is very important. So it has been loaded, all the functions have been the functions have been replaced, all the functions have been replaced with their addresses in the memory. So at this point the program will know where to jump and when it wants to call those functions and all. So finally it knows, the malicious program will know where to jump. Where to jump means where it has to reach the memory of the operating system and when it wants to call those functions and all while executing this malicious file. So the second thing I want to make it clear is in import address table ordinals. So APIs don't need to specify it by the name in the import address table. They can also specify it by the ordinal also. So ordinal is nothing but just a numeric offset to the functions within the DLL. This means that when you look at an import address table, you might see the functions specified by the number instead of a name. Here in this picture you can say, right? So before in previous slide we are having under kernel32.dll the import address table, it has the functions, virtual allocation is there, say for example read file is there, write file is there. For instead of that it has been represented with the ordinal number, ordinal 0001, ordinal 0002, ordinal 0003. So this means that when you look at the import address table, you might see the functions specified by the number instead of the name. So however, the process still works the same. The loader will determine what the memory address of the function is. It will replace it in the program import address table. So by seeing the OS memory, it knows which memory allocation it has to replace in the import address table. So by mapping the ordinal number in the OS memory. So virtual allocation, virtual is actually the function which has been already loaded in this memory position, which is been mapped with the ordinal number of 001, and it has been easily mapped here in the import address table also. So a common anti-analysis trick by the packers and the malware authors is to only use the ordinal values in the import address table and not the function's name, which I have said earlier in this slide. So they have been using mostly the malware malicious authors will use the ordinal numbers. So most of the tools can tell us what we are going to see in the nearby demo. Most of the tools can tell us what are all the ordinals name is, and what if they can't, we can find this through a Google search. So every tool it will tell what is actually the ordinal name is. If it is a 0001, it is actually virtual alloc. So, and if it couldn't, that tool couldn't tell the ordinal's name corresponding to its number, we can easily find this through a Google search and all. So, and finally in the import address table, the very important thing is application programming interface. So it is also present in this import address table. As I said earlier, import address table consists of the supporting files where it has to be located, where it has to find out in the particular location of the OS, which is actually the victim machine. So it will find every supporting files from the victim machine itself, and it gets loaded. Say for example a DLL file, it should get loaded. Say for example it could load the functions which is present in the OS memory, and finally it also get the APIs from the victim machine itself. So there are thousands of APIs out there, right? So you do a research on API. API is actually a very good concept. As a developer, we all should know what is mean the API and what are the different APIs present in the operating system. So common APIs you should be familiar with, right? You have to familiar with the common API. As a malware analyst, you have to familiar with the common APIs. So these are all the common APIs I have shown here in the pictures. For memory operations, we are having 3 common APIs: virtual alloc, virtual protect, virtual free. And for file operations, it is create file, read file, write file, delete file. If a malicious program I am executing, if it drops any folder in your program data, or if it drops any file in your Windows System 32 folder, then it has to call this API create file. Then it has to do some execution. If it does want to do some execution, then it has to call this API write file. So similarly, if it wants to do if that malicious file want to put some entry in the registries, then they have to call this API reg create key, reg. If it wants to delete some key, then they have to call this API reg delete key. So reg similarly for reg get value, reg set value x, reg set key value. So these are all the very common APIs you have to look it into as a malware research analyst. And for network operations, connect, accept, send, receive, listen, interconnect, internet connect, internet read file, internet write file, get host by address, get host by name. So these are all very common APIs every malware analyst should know. Some APIs are there: load library, get proc address. Is the debugger present is a very important thing. If this API is there in a particular malicious file in the P header, then we came to know that malicious author is using some anti-analysis technique. They are actually checking whether we have been debugging that malicious file or not, whether we have been analyzing that file or not. That malware author is actually checking. So is the debugger is present or not. So write, process memory, create remote thread, everything is actually important. So a lot of malwares that import functions that never get called. So say for example, if a malicious file it is getting executed, it consists of number of, say for example, it consists of number of APIs. This is because it should looks like a legitimate file. So and have been used to make the malware look more legitimate by having a large import address table. So you should concentrate if this malicious file is actually having a number of APIs, number of import address table, then the malware author is tried to make that file is actually a legitimate file. So we have to make a note on that also. So so these are actually been considering here for the import address table, right? So what are the things we have seen in the import address table is actually basic thing, import address table, and an example for import address table, and then ordinals, and then APIs, and finally resources. For a particular malicious file, resources are anything the program needs to run. If a program want to run, if a particular malicious file want to run, it needs some resources. So it is actually the raw data which is attached with that malicious program itself. So that is actually the resources. For example, icon. We have seen a HDFC statement.exe file that is actually having the icon of a PDF, Adobe PDF. So that has been stored here in this resources section of the PE header. So icon, a resource actually, a image, it is actually a resources. As are any menus that GUI programs needs. If that malicious file, if it exhibits GUI mode, then it has been stored in this resources. So malware uses resources to store hidden executables. Also, they drop or configuration files they use. So malware authors, they used to hidden some executable files in the resources sections also. They will drop or the configuration files that have been used for executing some more actions to be performed. So say here in the right hand side I have said one example. One of the ways that Trojan horses used in the social engineering attacks work is by discussing themselves as a documents. So it seems like a legitimate document. Say for example in social engineering attacks, say for example in a Facebook, it looks like a legitimate document that has been covering themselves as a documents, but within that document it has some executable scripts. So in this malware, in this Trojan, a small benign a document is often stored as a resources. That document may be displayed to the users after the program is executed. So this will trick the users to think everything is actually going good. So maybe some benign document is there along with the malicious script also there in this resources. So malware author used this resources section to do this kind of thing. So icons is there, images is there, menus is there for GUI mode, and hidden executables is there, configuration file is there, fake document is also there. So also we can find different languages. Programmers could specify a language associated with the specific resources, so that their program could be used for different languages and all. So languages of the resources tell the geographical region of the malware that has been created or not. So it has this timestamps and also the resource languages also. Here in the picture it has been shown that English United States, maybe the malware has been created at the United States. Maybe here it is Russian, maybe created by a Russian malware author. So we will see a demo in the next section. Thank you.